Nitric acid, which is also known as aqua fortis, meaning strong water, or spirit of nitre. It is highly corrosive in nature, or one of the, you can say, corrosive mineral acid. It is a mineral acid because it is found in earth crust. It was first recorded in 800 AD by alchemist Jabir in Hayyan. Formula HNO3, molar mass 63, density 1.51, boiling point 83 degree and melting point minus 40 degree. It's a very strong acid, and nitric acid is one of the acid which is present in acid rain. Now question arises, how it is present in acid rain? In atmosphere, the various vehicles releases their byproducts or waste gases. So various oxides are nitrogen has been released from vehicles to the atmosphere as a pollutant, and when rainfall takes place, it converts into the nitric acid which comes to the earth from the sky as acid rain. Now, how it is being prepared? The nitric acid can easily be commercially prepared by the oxidation of anhydrous ammonia to nitric oxide in the presence of platinum as a catalyst, and this process is known as Ostwald process, which is the most common process being used for the preparation of nitric acid. So in this chapter we'll further study more about the nitric acid and how it is being prepared. In the laboratory, it can also be prepared by treating, you can say, beta salt potassium nitrate with concentrated sulfuric acid at temperature less than 200 degrees Celsius to form the nitric acid. It can also be prepared by other beta salt, that is sodium nitrate with concentrated sulfuric acid. It also releases the concentrated form of nitric acid. Now, the vapors condense to light yellow after some time. Now question arises, why? Because nitric acid are unstable to sunlight or heat or to light. It easily get decomposed to oxides of nitrogen, and as the presence of oxides of nitrogen turns acid into yellow, then adding excess of water, the NO2 dissolve and it becomes transparent. This is the reason that dilute nitric acid is transparent in color, but the concentrated is slightly yellow due to the presence of oxides of nitrogen. Now, what precautions we have to take? Nitric acid attacks rubber cork, that is why only glass apparatus is being used. HCl cannot be used instead of H2SO4 because HCl will have volatile HCl vapors which can hinder the process. If reaction temperature exceeds 200 degree, then what will happen? If the reaction temperature, as we have seen in the lab preparation, has been maintained less than 200 degree, but what will happen if it is exceeding? If it exceeding, the sodium sulfate will be formed on the walls of the retort glass, which can damage the glass apparatus, and further it cannot be decomposed. Now, properties and uses of nitric acid. Nitric acid is a colorless fuming acid. Why fuming acid? Because in concentrated form, continuously it is getting decomposed into oxides of nitrogen, which has been seen in the form of vapors continuously coming out, so it is been fuming. The molecular formula already been discussed, that is HNO3, and molar density, that all we have discussed already in the previous topic. Pure nitric acid only exists at minus 41 degrees Celsius in the form of snow white crystals, which when liquefy into nitrogen pentaoxide and water bypassing current or dry air through this, and liquid removes the presence of N2O5, leaving a colorless liquid with a 98% content of nitric acid. In this chapter, we'll further study more about nitric acid chemical and oxidizing properties. In class 10th itself, we have studied that nitric acid is having the oxidizing properties. It is a powerful oxidizing agent. It reacts vigorously with many metals and non-metallic compounds. The reaction can be explosive in nature. Why explosive in nature? Because it is highly exothermic, an enormous amount of heat is being released. The oxidizing property of nitric acid is because of what? Why it is having an oxidizing property? Nitric acid is having oxidizing property because it gives nascent oxygen. Nascent oxygen means freshly prepared oxygen. Nitric acid is unstable to heat in concentrated form or in dilute form. It soon decomposes itself when reacts with heat to nitrogen dioxide in concentrated form and nitrous oxide in dilute form, along with releasing nascent oxygen. Nitric acid also reacts with metal and reduces itself into various oxides of nitrogen or ammonia. Ammonia further oxidized to give nitric acid. Then, depending on the concentration of acid, the activity of nitric acid with metals also vary. With very active metals like manganese, magnesium, calcium, it gives hydrogen. Means they're highly reactive metals, but it gives hydrogen, but the concentration should be very, very dilute. Means in highly dilute form only nitric acid reacts with manganese, magnesium and calcium. This is very important to note, that with manganese, magnesium and calcium it gives hydrogen. Otherwise, nitric acid is a strong oxidizing agent. Whenever it reacts with metal, it gives oxides of nitrogen. Only manganese and magnesium, calcium, it gives hydrogen gas. So since nitric acid is having the oxidizing agent properties, so with other metals it gives oxides of nitrogen, but with these three it gives hydrogen gas but in dilute form. Now coming to the other physical properties of nitric acid, it is yellowish brown in color, as we have already discussed, due to the presence of oxides of nitrogen. Fumes of air is always present in it. It is soluble, corrosive in nature, and various oxides of nitrogen are soluble in water. That is why it is a part of acid rain. Now coming to the chemical properties. Before discussing the chemical properties, let us discuss the stability. On exposure to heat and light, it decomposes to give nitrogen dioxide. As on exposure to heat, it gives nitrogen, various oxides of nitrogen. So that is why it is yellow in color. While storage in concentrated form, we can see the yellow color liquid due to the presence of soluble oxides of nitrogen. So here the reaction is also given. It is an acidic in nature, or we can say monobasic. Why it is monobasic? Because in aqueous form it releases one proton ion. On adding a drop of nitric acid, it gives the acidic test. Blue litmus red turns red, methyl orange turns pink, phenolphthalein remains colorless. Now coming to the general reaction with alkalis and bases. Alkali soluble bases. So with alkali it gives neutralization reaction. It reacts with metal oxides, it gives salt and water. Other bicarbonates and carbonates also it gives nitrates, release carbon dioxide and water. With metal sulfide it gives salt, water and sulfur dioxide. And the less active metals like copper, silver, lead, it gives nitrous oxide in dilute form and ammonium nitrate with very, very dilute form. The concentrated nitric acid gives NO2 with active metals like zinc and lead. So with zinc it gives NO2, and with less active metals it gives, with non-metals also it gives a good reaction. With non-metals also it reacts except silicon and halogen, and usually it oxidizes them into higher oxidation state. So here also with non-metal also it shows its oxidizing behavior and oxidizes the non-metals like carbon to carbon dioxide in concentrated form and carbon to carbon dioxide form in dilute. In both cases it oxidizes the metal. Uses: it is widely used in the manufacture of dyes and drugs and explosives as TNT, trinitrotoluene. Various salts of nitric acid is used as fertilizers. It is also used in the purification of silver and gold, and major use of making the stainless steel. It has also been used as a chemical doping agent for organic semiconductors at low concentration level. It gives used as artificially aged pine and maple form. So these are the various uses, we can go through it, and these are the completing the nitric acid content.